Hello everyone, in this video I have 4 balls and 3 boxes and I'm going to fill in these columns, this is the second video of the 12-fold way. We first have this first column and we have 1, 2, 3, 4 distinguished balls with 1, 2, 3 distinguished boxes. Box A, Box B, and Box C. And for choice A, there are no restrictions, so there can be like 0, 0, 4 or 0, 1, 3 balls in these boxes. And so for the first ball, it has 3 choices to go into. For the second ball, 3, third ball, 3, and for the fourth ball, also 3. And now, or it can be 3 to the power 4, which is equal to 81. And now we have B, which says at least 1 per box. And since there has to be at least 1 per box, it will be 81 minus, because since it's at least, we're going to do everything subtracted by the opposite. So the opposite, which means at least 1 box, has 0 balls in it. So first, we're going to use the video from before, and the last video that I did of the 12-fold way was us having 4 balls and 2 boxes. And in that video, for this column, I got an answer of 14. I got an answer of 14 in my last video. And so we're going to use this answer to help us find for the answer of in this video of this column. So it will be 81 every combination subtracted by. So since we need to subtract it by at least 1 box having 0 balls, it can be like 0 balls for A, 0 balls, and 4 balls here. 0, 4, 0, 4, 0, 0. There are 3 ways 2 boxes can have 0 balls, so that will be 3 multiplied by 2 boxes having 0 balls. And we found that in our last video for this column, and that was the answer of 14. And now we also have to subtract 81 by just exactly 1 box having 0 balls, which can be 0, 0, something that adds up to 4. And 0 could be here, and something that adds up to 4. Or the 0 could be here, and something that adds up to 4. So that is a total of 3. And so we're going to add 3 to this. And if we calculate this, we have 81 minus 45. And if we subtract this, we have 36. So that will be our answer for this column. 81 minus 45, which is equal to 36. Okay. So let me just fill in the columns with choice C, because again, just like in the last video, since there are more balls than boxes, the number of balls than boxes, there cannot be more than 1. It is impossible to follow the rule, choice C, which says no more than 1 ball per box, because then at least 1 ball would not be able to go into any box. There would be 0 ways or 0 outcomes for all of the columns that are supposed to follow the rule choice C. And now time to solve for this one, which we have 1, 2, 3, 4 distinguished balls and 1, 2, 3 indistinguished indistinguished boxes, and there are no restrictions. First, we're going to write out the arrangements there can be for how many numbers are there in each of the boxes. There could be 0, 0, 4, 0, 1, 3, 0, 2, 2, and 0, 2, 2, 1, 1, 2. That was the last one. And the number of ways this arrangement can happen would be only one way. And for this one, that will be 4 choose 1, which is equal to 4. For this one, that will be 4 choose 2 divided by 2, because there are 2 same number of balls going into different boxes. So 2, 2. And so that will be 6 divided by 2, which is 3. And for this one, it's the same, except it is 4 choose 1 multiplied by 4 choose 1 divided by 2. So in this one, we had to do one more of the choosing, because in here, since there were zero balls going to this box, we did not even have to think about the 0 here, since that would have been the same problem as 4 distinguished balls going into just 2 boxes. But here we have 1, 1, 2. There are no 0 balls going to a box. And also we could have done 4 choose 2 and then 4 choose 1. It does not matter at the end. And so this answer is 8. And so that is a total of 5, 8, 16. So the answer is 16. Oh wait, no, I just realized the problem. A mistake that I made here. It would have been 3 choose 1 for the second part, because since we already choose 1 from here, we would have 3 balls left. So that would be 6. And that would give us an answer of 14. And now for B, we have to have at least 1 ball per box. So we can cross out this arrangement and this, giving us just 6 arrangements, or just 6 ways. And now for this column, we have 4 indistinguished balls with 3 distinguished boxes. Boxes A, B, and C. How many ways can these 4 balls go into the 3 boxes? We're going to write out the arrangements. There could be 0 balls in box A, 0, 4, or 1, 0, 1, 3, 0, 2, 2, or 1, 1, 2. There are only 2 arrangements that you can make. And for this to happen, there are only 3 ways, because if the boxes were indistinguished, then there would be only 1 way. But since the boxes are actually distinguished, there could be 4 balls in C, or B, or A. So that is a total of 3 ways. And for this one, it would be 4 multiplied by the number of ways to mix these 3 numbers up, which would be 6 factorial. Wait, no, not 6 factorial, 3 factorial, which is 6. Wait. Okay. Yeah. It's not 4 multiplied by 6, because it's even if the boxes were indistinguished, it would not be 4 ways this arrangement can happen, because the balls are indistinguished, and it would just be 1 multiplied by 3. So that's, oh wait, no, 1 multiplied by 6. So it would just be 6 here. Because since the balls are indistinguished and not distinguished, it can just be 0 balls in this box. 1 ball is 3 balls. So the balls are not different. So this would be the only arrangement. And we can just mix up these 3 since the boxes are distinguished. And now for this one, it would be 1 way, again, multiplied by 3, because the number of ways 0, but with the number of ways, you can mix these 3 numbers up. So 3, yes, just 3. And for this one, it is also 3. And if we add these up, that will be 15. Now for B, there has to be at least 1 ball per box. And so we can just cross this, and this one out, which will just make 3. I'll erase this now and we can do the next columns. Okay, now for this column, we have all of the balls and boxes are indistinguished. And there are no restrictions. So we're going to now write out the arrangements. 0, 0, 4, 0, 1, 3, 0, 2, 2, 1, 1, 2 for the last one. For this one, it will just be all 1 ways for all of these arrangements since the balls and the boxes are indistinguished, and it would not matter if they were mixed up. So like if it wouldn't matter if the boxes were mixed up, it wouldn't matter if the balls were mixed up. So this would make a total of 4. And for B, at least 1 ball per box, we can cross this one, and this one out, making just 1. I managed to fill out this chart for the 12-fold way a little bit faster in this video, so I'll see you guys in the next video, the 3rd video of the 12-fold way.